So this first set of lessons is all just different factoring methods. In this lesson, we're going to start to look at factoring by grouping. So we basically already have two types of factoring, right? We have GCF, or greatest common factor, and the difference of perfect squares. This method, we're going to actually start in the middle. So this set of factoring problems in exercise 1, you're actually already partway into factoring by grouping. So looking at the first one, I have these two sections of my problem. I'm looking at them, both of them have a 2x plus 1 in common. So that's actually a binomial or two-term GCF. So just like with the GCF, we divide it out and put it in the front. If I divide both of these by 2x plus 1, it's going to cancel out, and then we put that in the front. What's left when it cancels is x plus 7. So it's just kind of recognizing that common binomial GCF. Okay, common, I said common twice because common is also in greatest common factor. So basically we're just looking for the binomial in common. Here, that binomial I have in common is that x minus 2. So I don't need to show the division, but that's what's happening. I take out the x minus 2, and I have 5x minus 4 left. So on the next couple of problems, we're going to have a little step after, but it's that same type of idea. Okay. So on this one, for example, my common binomial factor is x minus 4, and I have 3x squared plus 3 left. Now we have to check, part of factoring is making sure we factored completely. So in that second binomial, the 3x squared plus 3, there's actually a 3 I can take out. Now, I'm going to show an extra step when I take out that 3, but ultimately, if I have any monomial single terms, which in this case is the 3, I'm going to bring that out to the front and put the other parts after. Okay, just for organizational purposes, it looks better, it's easier to read if the monomials in the front. So looking at the next one, and you can try a couple of these ahead at any point. That's good to try to make sure you understand what's going on by doing them by yourself. But here I'm taking out the 2x plus 1, and I have x squared minus 9. So checking that second binomial, this time I have difference of perfect squares. So this becomes x plus 3, x minus 3 from the last lesson, and this is 2x plus 1. So E and F are ones that don't really look like this grouping pattern, but I can make them into it. So here, I see an x plus 3, I see another x plus 3. If I put it in parentheses and put a 1 in front of it, I haven't changed anything, right? That's still x plus 3. But then I see the structure to take out the binomial factor. So this is x plus 3, and then x squared plus 1. Now, tempting to try difference of perfect squares here, but it's a sum, not a difference, so that one's done. The next one is just one step up from there. This is the opposite of this. So we can rewrite this. I'm just going to rewrite it. Usually you could cross stuff out, but since it's the first one, if I factor out a negative 1 from these two terms, my x becomes positive and my positive 2 becomes negative. So then I can factor out, now I have a common binomial factor of x minus 2. And I have 4x squared minus 1 left. So here's difference of perfect squares. Not related to this factoring out the negative 1. It's just that 4x squared minus 1 happens to be difference of perfect squares. So that's what I would do to finish off the factoring. Now, there are some little mistakes that come up with grouping. We're going to look at one in the next problem, and this also kind of introduces the full process. Oops, wrong problem. Never mind. Not a mistake here. This is how we do the full process, and this is why it works. So here we have 4 terms, and that's kind of how I recognize I need grouping. Now, to create that common binomial factor, I group my terms. So this is an addition problem with 4 parts, and I say I'm going to do these 2 together, and I'm going to do these 2 together. So if we think of those properties from that very first lesson, when I get to pick what I do first, that's the associative property. And then my next step, once I have them grouped into those 2 sections, is to take a GCF out of each one. So here, my common factor is 2x squared, right? And if I take out a 2x squared from those 2, I get x minus 3. And here, my common factor is 5. So if I take out that 5, I also have an x minus 3. Now, anytime we're GCF factoring, we're really doing the distributive property in reverse. And that's the distributive property of multiplication over addition. I'm just going to write the one word for now. So now we're set up here. Now I'm going to take out a GCF again, but this time it's a binomial GCF, but that's fine. If this is reverse distribution again, so this is once again taking something out, opposite of distributive property. So we use basically the distributive property 2 times in the grouping factoring method. So to summarize, when we factor by grouping, we first extract common factors from pairs of binomials in 4-term polynomials. So we extracted common factors from pairs of binomials in 4-term polynomials. If we are lucky, we are left with a common binomial factor, right? And we can take that out. So we're going to do practice on the next page, but that's the basic idea of the method.